All right, so this is just a recap, a review of what we've covered in 6.1 through 6.3 for the test on polygons. All right, 6.1 was reflectional symmetry and rotational symmetry. Sometimes reflectional symmetry is called line symmetry, and sometimes rotational symmetry is called point symmetry. With reflectional symmetry, you just have to know how to draw or count or identify lines of symmetry. So, for example, a heart has one line of symmetry. A star has 5 lines of symmetry. Okay? With rotational symmetry, there is a bit more to it. Rotational symmetry is how many times a figure can rotate and look exactly the same as it did before you rotated it. So a star, for example, can have 5 positions, 1, 2, 3, 4, 5, where when you rotate it, it looks exactly the same. So we say it has an order of 5, and we have an angle of rotation would be 360 divided by the order. Right? So the angle is always 360 divided by the order. That gives you the angle at which this rotates. So since it goes 360 all the way around, that's why we divide by the number of times we rotate it, and we get the angle. So that's pretty much it for 6.1. 6.2. 6.2 we talked about nope, not yet. 6.2 we talked about angles in polygons. And we talked about exterior angles, we talked about interior angles. There are a few things that they could ask you about interior angles or exterior angles. In both cases, a significant number would be the sum. And in this case, the sum of the interior angles has a formula. 180 times n minus 2. That gives you the sum, right, of interior angles, where n is the number of sides. Exterior angles, the sum is always what? 360. No formula there. It's always 360. Okay? Well, something else that they could ask you about involves regular polygons. What does regular polygons mean? What does it mean if it's regular? Yep. All the sides are congruent, all the angles are congruent. So remember what that's called? Equiangular and equilateral. So equilateral is equal sides, equiangular is equal angles in regular polygons. I forgot to mention in 6, I guess in either one of these, maybe it was 6.2 that we talked about, all of the names of the polygons, right? You should know pentagon, hexagon, heptagon, nonagon, octagon, decagon, dodecagon, right? You should know all of those names that we listed in that chart. Remember that chart? Okay, so make sure you know what those are. Anyway, regular polygons, all the sides are congruent and all the angles are congruent, which gives you something significant. They might ask you, instead of the sum, they might ask you the measure of one interior angle. or the measure of one exterior angle. In both cases, finding the measure of one of the angles is going to require you to divide by the number of sides, right? So here, if you have an interior angles, you could take the sum, oops, parenthesis in the wrong spot, take the sum and divide by the number of sides. That gives you the measure of one interior angle. With the measure of one exterior angle, since the sum is always 360, it's just going to be 360 divided by the number of sides. Gives you the measure of one exterior angle. We should also note here that for regular polygons, n can also be found by doing 360 divided by the measure of one exterior angle, right? If you divide that, you would get the number of sides. Did I miss anything in that section? Some of the interior, some of the exterior, regular. There were other vocabulary words in there like concave and convex and all of those things, right? Oh, we what? Well, we did that. Keep that thing out of your ear and you'll be able to hear it. Okay. The other thing, though, you did remind me, remember that the measure of one interior angle plus the measure of one exterior angle equals what? 180, because they're a linear pair. So remember, we had kind of two different ways of solving some of these problems. Sometimes we can use exterior angles and it's a little easier because one interior plus one exterior equals 180 because they're a linear pair. Yep. Go back up. All right, so that's the other thing I want to mention. Okay, and then the last section. Yeah, the last section is on finding the area of regular polygons. Yep. Are we good now? Okay, so 6-3, area, 1/2 AP, where A is the apothem and P is the perimeter. And in a polygon, you're always going to highlight this triangle here, which is always drawn using the apothem on one side, going straight down perpendicular to the side. This side is called the radius. And here, this is 1/2 a side of the original polygon, right? So you've got the apothem, the radius, and 1/2 a side, making that triangle, and that's the triangle you're going to focus on. So, in that triangle, if you have either a hexagon, 6 sides, or an equilateral triangle, or a square, you're going to have special rights hiding inside them. Now, the most important one to focus on for you for studying is hexagon. That special right triangle is a 30, 60, 90 triangle, where the 60 degrees is here, the 30 degrees is there. This is the apothem, right? So the length of a side, if the length of the side is, let's say, 10, that makes this 5, and the apothem would be 5√3. There's no SOHCAHTOA on the test. Okay.